The vertex of a quadratic function is this point right here. It's the turning point of the graph. So we have a negative slope, negative slope, negative slope, get to the vertex, and then we start to have a positive slope. Another way to think about the vertex is the point where the parabola crosses the line of symmetry. So if I were to draw a really nice straight, pretty good line of symmetry, then the vertex is the only point on the parabola that is on that line of symmetry. When we're trying to find the vertex, again, it was really easy when we had our function written in vertex form. We just found the vertex as that ordered pair h and k directly given in the function rule. In standard form, we have to do some work. Now, since the vertex is the point where the parabola crosses the line of symmetry, that means we need to find the line of symmetry first in order to have the x-coordinate of the vertex. So I find the x-coordinate of the vertex just using that same formula, opposite of b over 2a, that I used to find the line of symmetry. So for this function rule, I have a equal to 1 and b equal to 4. So my vertex x-coordinate is opposite of 4 over 2 times 1, which is x equal to negative 2. That means I right away have my x-coordinate of my vertex, and we can see that that's right. X is negative 2. Now, if we were to look at that last toolkit that I did on line of symmetry, this is the same function. This is exactly the same work that I did for the line of symmetry. So if I had already found the line of symmetry, I wouldn't have needed to perform these calculations. I would already have my x-coordinate. My x-coordinate is negative 2. In order to find the y-coordinate, I just need to plug that x value back into my function rule in order to find y. So I'm finding k of negative 2, if you remember function notation. That means the y value, or the output of the function when x is negative 2. So I need to do negative 2 in parentheses squared, plus 4 times negative 2 plus 1. So negative 2 times negative 2 is 4. 4 times negative 2 is negative 8 plus 1. Just going from left to right, I have 4 minus 8 is negative 4, then plus 1. So my y value when x is negative 2 is negative 4 plus 1, which is negative 3. I'm going to go ahead and rewrite this vertex in a different color so that it stands out a bit with my work. So my x-coordinate was negative 2, and now my y-coordinate is negative 3. And looking at my graph, I know that I'm right. X is negative 2, y is negative 3. For these other two examples, notice that these are the same function rules that I used on my line of symmetry toolkit. So I can do the work again, finding the x-coordinate opposite of b over 2a. So opposite of negative 8 is positive 8. 2a is 2 times 2. And 8 divided by 4 is 2. So the x-coordinate of this vertex is 2. But since I already had this toolkit, I could have just taken this x-coordinate from this toolkit. Same exact function, same exact work. I get the x-coordinate of my vertex from my line of symmetry. Now I need to find f of 2 in order to find the y-coordinate. So 2 times 2 squared minus 8 times 2 plus 5. Order of operations, it happens to not, it does matter here. So I have to do my exponent first, 4, and then multiply it by 2. So 2 times 4, not 2 times 2 squared. So this is not 4 squared. I need to square the 2 first and then multiply it by 2. Minus 16 plus 5. A little tight on space here. 2 times 4 is 8. 8 minus 16 plus 5, which is negative 8 plus 5, which is negative 3. All right, so I have my x-coordinate of my vertex and my y-coordinate. My x-coordinate is 2. Again, that directly matches my line of symmetry's x-coordinate. And then my y-coordinate is negative 3. For this example, I'm going to, since space was so tight here, I'm just going to get my x coordinate from my other toolkit since I already did that work. X would be opposite of b over 2a, -6 over 2 times -1. So -6 over -2, which is 3. Hopefully that's what I got over here. Yep, so I'm just going to get my work from my line of symmetry toolkit, x equals 3. Again, if you're given a function rule and are asked to find the line of symmetry in the vertex, when you're finding the vertex, you don't have to do that work again. Just obtain your x from your line of symmetry. In order to find the y coordinate, I need to find f of 3. In other words, I need to plug 3 into my function rule to find the output, or y. So -3 squared. If you're having a hard time with this evaluation, you should go back and do that evaluating quadratics toolkit. Plus 6 times 3 minus 3. This is equivalent to an invisible coefficient of -1, so I'm going to do -1 times 3 squared, which is 9, plus 6 times 3, which is 18, minus 3. -1 times 9 is -9, plus 18 minus 3. Gosh, space is still tight. Is 9 minus 3, which is 6. That means my y coordinate of my vertex of my function is 6. So I am now done. My vertex of f of x equal to -x squared plus 6x minus 3 is x equals 3, y equals 6.